Good morning. First, thank you guys for coming. 9 a.m. on a Friday is actually the best slot because we know you guys are interested. Welcome to Scaling Infrastructure Operations with AWS Service Catalog, AWS Config, and Cloud Trail. My name is Prashant Prahlad, and my colleague Abhishek Lal. We're going to go through some details about Service Catalog, Cloud Trail, and Config, and how you can use this to scale infrastructure operations. So this is actually a really good slot. So I think we should all congratulate each other for coming here at 9 o'clock in the morning after the party last night. And also, it's a good slot because you probably got a lot of information over the last 2 days that you it's all hazy at this point. You probably forgot everything after party. So this is, you're soaking this up as new information, which is really good. All right, let's get started. So through this session, what we're going to do is learn how you can scale infrastructure administration through standardization. So if you standardize, log what's happening with your account, detect when something different happens, and then correct it, you'll be able to scale operations without hiring an army of people to help. You learn how you can codify best practices for scaling operations and detecting errors through config rules, which is a new capability we launched recently. And security operations and developer posture and operating posture actually improves as a result without actually affecting how developers use your product. So they continue to use AWS the way they used to, and these things are just operating in the background without affecting them. So we know growth is good. In fact, it's great. Right? Who doesn't want to see this kind of a graph? It's your unicorn. It's the hockey stick that everyone wants to achieve. And at AWS, we've seen a lot of our customers and various companies actually operate this way. It's not necessarily startups, but it's also teams within enterprises who have actually started projects on AWS, who are starting to build products. They typically start off like this. They're in the phase early on where they're experimenting. There's two developers on the project. They're trying to figure out how they're going to use AWS, what products they're going to build. And they have a few instances. They make a few API calls. It's typically a single application. And then they launch the product, or they launch the company if it's a startup. And you have several developers. You get a lot of attention. You start building out your services. And then after a while, you have new people coming in, new developers who are new to the product, sometimes new to AWS. You see they're making hundreds of API calls. You have customers using the product, so you can't actually take it down and take it down for maintenance and things like that. And you have, within a year's time, we've seen this scale to tens of apps and services. You have thousands of API actions happening every month. And you have hundreds of customers. So this is not atypical of the growth we've seen when new products are launched or new companies are launched that are using AWS. And this is all great, right? What could be wrong? The thing that we've seen is that you have to make investments early on to scale to that without having to essentially hire a lot more people. So one of the things we've seen is you have to just assume you're going to grow, right? You have to make sure that your system is set up such that new users can actually experiment and assume that they're going to make mistakes. Like, not everyone gets this right. You have to assume that they're not going to just use their laptops to start accessing the cloud. They have various methods now to access various devices to access the cloud. They will never give up self-service access to infrastructure. It's a superpower that developers have, and it's just so important now for agility and the access to all of these resources that it's just hard to take away. And it's not necessary that all of them are working in the same place. You have developers working all in different locations, and all of them are communicating through Slack. Right? It's all about chat ops. So all of these things are things we think companies should assume when they're starting to scale infrastructure. It comes with a set of challenges. So you have various developers, and some of them are absolutely new to AWS. They're well-intentioned, they're eager to learn, they're starting to get used to AWS, they come in and they want to have an impact. You just don't want them to have the wrong impact, right? The mistakes can be expensive, right? And unfortunately, when you also scale, you can have checks and balances in place, which sometimes makes developers less productive than they need to be. You have to get approvals and you have to get sign-offs from people. And that can be, to a developer, it can be something that prevents they see it as not being productive. And also, operating and troubleshooting. If you're troubleshooting an error, if you have various people doing various things trying to make the project work, just troubleshooting that becomes so much harder because there are just so many flavors you have to now understand, debug, and troubleshoot fairly quickly. And then if you're using Slack, you're going to see a lot of noise in the Slack channel just because pretty much everything is on Slack. So growth can be challenging, but you have options. There are options available. So one is that your status quo, you decentralize, you give complete control to developers, allow them to experiment, give them all the tools they need to be productive. And you have a set of documents that you can write and say, hey, guys, follow these guidelines so we can actually operate better. And if you're like me, you'd say, I have to get stuff done, and I can interpret that guideline to mean something else and make errors, right? So it's a double-edged sword. I can be productive, but I can also, misinterpret what is recommended as a guideline. The other option is for you to lock it down and then be the approver for each of those changes, right? You could say every deployment goes through me so I can actually understand what's going on. I'm the administrator, I'm the operator here. Developers lose agility, and as we said, it's like taking away a superpower from a superhero. So it's very unappealing to developers when you lock down and approve. And it always also scales to the number of approvers. So if you're willing to duplicate yourself, that's the only way you can lock down and approve as you grow. So are these the only options?
Maybe not. Maybe there is a new hope. Good morning, guys. I'm Abhishek Lal. I'm a product manager for AWS CloudFormation and Service Catalog. So Prashant set up a couple of options. But how about we think of a new way? Self-service, self-govern, and do it at scale. What does that mean? Andy said this well in his keynote, where he said that we all come into work to do meaningful work. And having that kind of access to infrastructure, technology, at our fingertips empowers us to do our best work. Now, this, of course, needs to be combined with the right goals of an organization. It has to be combined with the right culture in your organization. And then the tooling can come and fulfill any gaps in there. The tooling can support the right goals and the right culture. But without the first two pillars, the third doesn't stand on its own. So what we will do in the rest of this presentation is try to say that once you have adopted goals of being an innovative organization, being an agile team within your group, how do we help you adopt the DevOps culture, be data-driven, do everything measurement, sharing, and what are the tools that we provide, the AWS management tools, which help you do infrastructure as code, self-service, auditing, and change tracking. That's what self-service and self-govern would look like at scale. There's several AWS management services. The first one we'll introduce today is AWS Service Catalog. If folks are familiar with this, this is the service which developers and end users or even administrators can use to browse and launch custom products. You get to define what a product is. You get to define the abstraction. of what a product is, whatever is relevant to your user, to your consumption. This is all self-service. You come, you find the products you want, you launch them. At that point, CloudFormation kicks in and actually provisions and tags all your infrastructure appropriately. Your infrastructure is created right. It is created using declarative templates which follow best practices, which follow compliance rules, which meet your business goals and meet your business policies. Once this infrastructure is in place and all the users are making use of it, there will be cases where users will use and modify these. And there should not be a reason for you to get in the way of that. Users should have access to all those services, except that you can use CloudTrail to track all the API calls. As users also change and modify the infrastructure pieces, AWS Config comes in to check on your configuration of all your resources. We will see how both these services combine together to give the admin or the person who's responsible for ensuring compliance and best practices as well as management of the infrastructure gets the right tools they need. How can they troubleshoot? How can they audit? And all of these services are hosted and managed by AWS. You don't have to install infrastructure. You don't have to buy tools, licenses. It's all pay as you go and all running in the cloud in there. So let me start with AWS Service Catalog. The Service Catalog allows organizations to create products and present them to their developers for self-service consumption. It really is the bridge of two conflicting requirements: control versus agility, standardization versus self-service, governance versus time to market. The Service Catalog fulfills both these needs. We'll see how it does it. Between an administrator and a user, the administrator first starts by creating a portfolio. A portfolio is a folder. This is essentially a set of services which you want to give to your constituency. We've heard folks do it by department. We've heard folks do it by customer if you are a service provider for several customers. But you create a portfolio. Within the portfolio, you add products which are defined using CloudFormation templates. CloudFormation is our infrastructure as code service. It lets you declaratively define all the resources, their relationships, their configurations, and all the tags which you need to put on individual resources. You can codify all of that. You can codify best practice architectures in these products. Once you've created a portfolio of products, you get to add constraints and grant access. So this is where another layer of control is built in. You choose which audience has access to which products, and you constrain the configurations which they can do within that. Let's say you want to create a demo and trial portfolio. You should not be provisioning 4x extra large instances there. Makes no sense, maybe. Or if you want to limit provisioning to certain regions or certain IP ranges, you do not want people opening up ports. Only port 80 should be opened up. All that can be codified as constraints and configured right. Right up front, your stacks are created with the right configuration. The end user comes in, and we'll see this. We'll see this in part of the demo. The end user comes in, looks through the catalog of products, launches products in a self-service manner. CloudFormation kicks in. It will go deploy any stacks which are needed. And at all times, events are available. So you have several ways of consuming those events. You can create an event stream. You can pipe them through a topic, or, as we will see with CloudTrail, all API actions which are done are being logged. Everything is being tracked. So with this picture in mind, The demo I want to show you has an interesting use case. The use case is that you as the administrator do not want to give end users access to all AWS services. Let's take that case in mind. And there could be several reasons for it. It could be just for reducing blast radius. It could be for you might be provisioning for customers. So hence there might be account separation, who owns the data, all those could be reasons. But in this case, you are going to use an IAM role which you create to always provision the resources. So what will happen is the user will go as self-service and try to provision. And on the back of it, you want to use your credentials and your admin role to provision on their behalf. But this does not mean that the user can impersonate you. The user can only provision what's in the catalog. This is very, very powerful separation. You'll see that in action. So in this demo, let me start off. I'm going to navigate to the Service Catalog console. And here I have a set of portfolios available. This is the administrator view. So I have a marketing department portfolio. I have a dev test portfolio. But I'm going to pick the demo portfolio for now. And within this portfolio, let me show you what are all the different constituents. You have products. So I've got a dev box and a website. I've got constraints. This is where I can add the constraint to say, use a particular role to launch a particular product. So let me do that quickly, where I'm going to add a particular constraint. And in here, I get to choose between which products I want to apply this on. So let me do it for the demo dev box. The constraint type is launch. Now, I have created a role already called admin. And this role has all the requisite permissions it needs to provision my product. So if it has EC2, S3 access, it has all of that available in there. And that's it. With that one simple gesture, I have now said that the catalog will provision this product using that particular role in there. Additional things I can do here is grant access to specific users, or I can share this across AWS accounts. So you can manage your portfolio centrally and share across accounts. You can see I've added a tag for cost center, and this will really help because now everything provisioned from this portfolio will get tagged appropriately. Let me switch to the end user console. A very clean look, a very simple way to see what are the products which are available to you and the stacks which you are running. On the top right, you'll notice I'm logged in as myself. This is my IAM user, which is logged in. Let me choose the demo product and look at all the details. Note launch option 1. It tells me it will use the admin role to launch this, limit some use cases, and set some specific tags. So let me go through that launch behavior now. You provide the stack name. So in this case, it is the simple dev box, which I'll set up. Choose a version. You can version your products in there. Let me select version 1. And here, I get to specify all the parameters which were made available to me. This user experience is data-driven and customizable. You get to ask questions like use case or whatever else you want to ask, and then make choices about configuration on that. As an end user, I can add additional tags, like specify my own project name. What I cannot do is remove tags which the administrator has put. So here, I review everything and click launch. This is self-service provisioning, but of infrastructure which was all pre-configured, validated, and met business goals and policies. My stack is up here and available. I can monitor its status. Currently shows as launching, and I can go and start using that once it is available. So what did we see today? We saw how AWS Service Catalog can play a key role in increasing agility through self-service. We saw how it promotes standardization and compliance by letting you codify that in your configurations and your infrastructure. And finally, we saw how you can tag resources, and that helps with permissions, with tracking, with chargeback, all of those cost-related dimensions. If you care about tagging, can be helpful there. I want to move to AWS Cloud Trail. This is our next management service that we'll see. Once all this infrastructure is provisioned, or even with the service catalog as the provisioning engine or using CloudFormation, folks are making API calls. Folks are using the console. Folks are making command line calls. All of these are being made to different levels of services. This could be IAM, RDS, like core services. These could be two management services like Catalog and CloudFormation. CloudTrail is continuously recording all of these API calls. It's storing them for you in an S3 bucket for archive, if that's the first purpose. It's making them available to you in the portal for troubleshooting, for really quick search. And you can log all of these logs into CloudWatch to actually set up monitoring and alarms for that. There are several use cases which CloudTrail will enable for you. Security analysis, track API calls, troubleshoot, demonstrate compliance. All of these are use cases which CloudTrail helps with. In this demo, let me show you what CloudTrail recorded for all the operations I just completed. Let me navigate to the CloudTrail console and bring up the recent log. Notice all of the different options which are available here, as well as I can do filtering. In this case, just to make it easier to read, let me filter by service catalog. Because I know service catalog was provisioning on behalf of the user, let me show you all the operations which was done on behalf of service catalog. I can set a time range if I want to limit the logs, or just see what were the most recent operations. Create stack looks interesting. What does it tell me? It tells me that the request came from a particular IP address, who was the source of the event, as well as what was the username. Now, I want to know more details. Just look at the detailed information which is now available to you. You can see what was the principal ID, who made the call, what was the role which did it, all the way down to what was the event time and extra information which was needed. As an admin, I had picked the admin role to provision all this, and all that is captured here. And here is the best part. Every parameter value that I specified, every input that I gave is all captured in this. This is tremendous because you can be asking customers for things like, hey, enter your approval code, hey, enter your badge ID, or anything like that. And now you have direct tracking of any information of what actions the user might have taken in there. So very, very powerful in terms of what it can log and what it can help you track in there. With CloudTrail, we see the ability to have a complete log of API actions. Several questions can be answered now. Who did this? What were the resources affected? What was the action that the user took? When did they take it? And where were they accessing the system from? All of these questions can be answered using CloudTrail logs. It enables faster resolution to issues, as well as you can set up alerts. So you, on a proactive basis, can look for actions which are inappropriate or malicious and flag them. With that, let me hand it back to Prashant to talk about our third management service, AWS Config.
Thanks, Abhishek. So you learned how you can standardize through Service Catalog. So you have a fixed set of things you have to debug. You can use CloudTrail to actually log what's happening. With AWS Config, you can actually go one step further. You can detect what's happening. You can look at the resources that are used in your account. You get a full inventory of what resources exist in your account and also what resources were deleted. With the capability we announced on Wednesday called config rules, you can actually set up rules that check the configurations that are recorded. So you can actually assess whether what's happening is in compliance with what you've defined as your own best practices. You can audit also historical configurations of resources. So you can look at a resource, let's say a VPC, and see if there's anything that's changed. In fact, the portfolio of the products that Abhishek provisioned, you can actually go look at a history of all of them through config. And also the service notifies you when a configuration of a resource changes, so you'll know exactly what changed on that configuration. So you'll get a diff of what it was before and what it was after, and then you can assess whether that's something that you approve or don't. Let's take a look at this in a lot more detail. So config does 4 things. It records changes that are happening to your infrastructure. It normalizes these changes in a consistent format called the configuration item. It stores them in a data store and makes this available through APIs. And it delivers this data. It delivers this data very similar to CloudTrail. It delivers it to S3, where you can store, archive it, or do offline analysis. It notifies you through SNS, simple notification service, so you can take an action based on that. And also, at any point, if you want to just check what's happening in your account, you can get a snapshot, which is a point-in-time view of your resources in your account. That's config. With config rules, we're adding a 5th step in this process. Not only records, normalizes, stores, and delivers, it also checks rules. Checks against rules that you've defined to see whether the configurations that are recorded are compliant with what you've defined as your own practices. Now, it's important to understand this little bit of detail about a configuration item. A configuration item actually represents a resource. It could be an EC2 instance, like Abhishek provisioned. It could be a security group, a VPC. All of these are normalized into this standard format. The configuration item consists of 5 different fields. It consists of metadata, which tells you whether the configuration item is details about the configuration item, such as version, the ID, and the time it was captured. It contains common attributes for these resources, so things like tags, availability zones, account ID that provision this resource. All of this is available in the common fields, regardless of what resource it is. Relationships. Now, when you provision a resource, you're typically not using it in isolation. You're using an EC2 instance along with volumes. You're using an EC2 instance in a VPC with security groups. Now, these are all intuitive to a lot of you who've used AWS often. But for someone new to understand the dependencies this resource has is actually codified in this configuration item. And then there's the current configuration, which is a full describe on that resource. So if you had code that was previously using a describe API to check things, you can actually use the current configuration field, and it will be perfectly compatible. And finally, related events. So this is how Service Catalog, CloudTrail, and Config are tied together. The API call, if there was an API call that caused a change in the resource, the related events field actually captures the ID of that API call that you can look up in CloudTrail, similar to what you saw in the demo. So this is what a real configuration item looks like. It's a JSON. This is for a volume. It has metadata in green, common attributes such as Amazon resource name, availability zone, resource types, and so on in orange. The relationships this volume has, this is attached to an EC2 instance, so you can see what that looks like here. And then the related events is a GUID that links back to a CloudTrail API call. And of course, the details of the volume itself. Now, let's see how you can use what this looks like in the console. Now, this is the AWS Config console, and here you can look up resources by type, or you can look it up by tag. So I'm going to go ahead and look up a resource by type. I'm going to select a VPC, in my account, I don't need to remember the VPC ID. I can just say, show me all the VPCs in this account. And I have one VPC here. I can click on that specific VPC. And then I'm taken to this page that contains all the configuration items recorded for that VPC. So we saw what a configuration item was. So here, I have 3 configuration items for that VPC. And it's telling me the changes that happened from the previous version of the configuration item recorded. Here, a network interface and an instance were added to that VPC. Now, you can also say there was a change that was submitted a few minutes before that. A security group was added to the VPC. So you have all of this data continuously being recorded without actually affecting how your end customer, the developer, is actually using this stuff. Now, what you're seeing in the UI here is a subset. If you click View Details, you'll see a lot of the configuration item. Now, you can also look up resources by tag. So let's say you tagged everything correctly using Service Catalog and CloudTrail, and you can just look up, using the tags you just provisioned. In this case, I'm using name. I can look up the resources. In this case, it's an EC2 instance. I can look up the EC2 instance and similarly come to the configuration items page or the config timeline. Now, what you're seeing in the UI is all available through APIs and CLI. So you can pretty much do everything you're seeing here on the CLI and through APIs. Now, I mentioned relationships. In this case, this instance was launched in a VPC. It has a network interface, a security group, a subnet, and a volume. I can click on any of these and similarly go to a timeline for those resources at that point in time. So I click on the VPC, and then I come back to the VPC that contains this resource, for example. So that's how AWS Config works today. With config rules, you can actually go one step further. This is a capability in preview. A config rule is a rule that checks the validity of the configuration recorded. So the configuration item that you saw a little while ago, you can check every field in that and say, hey, this looks good, or this looks suspect. I want to do something about it. There are 2 types of rules you can use. One is the AWS managed rules, and these are rules that we will pre-create for you that you can just click and enable. So these are essentially pre-coded, and you can configure them to meet your specific requirements. And we'll look at this in a little bit more detail. Or you can write your own rule. So you could say, my organization has its own practices that I want to codify. Instead of having this compliance document or best practices document, I'm just going to write it in code. And you write it using AWS Lambda. So all the languages that Lambda supports, Python, Java, JavaScript, all of these are available. You can use any of them. You run these rules in your account, and you maintain them to make sure that they're working correctly. So let's see what you can do with this, right? You can actually you can be a security person and make sure that the configurations that are recorded are safe. You can actually use this data for auditing. If you're subject to compliance audits, this data is one of the sources they could use to assess your compliance. You could use it for change management, and this is an interesting use case where you could say, I'm going to make a change to this particular resource. Show me the blast radius. Show me all the things that are connected to it so I can understand what the effect of this change could be. Troubleshooting and is always useful to know what exactly changed, so you can go back and look at if that change actually affected something else. And finally, you can just discover what exists and what was deleted in your account. Let's see how you can actually set up a config rule in your account. So here, Abhishek provisioned a web app that he started using, and I'm going to set up a rule because I'm really paranoid. I think that he's going to do something to be productive. He's going to start opening some ports that I'm very paranoid about.
Come on.
Well, we'll see. So I'm going to add a rule here that AWS has predefined. So we have I mentioned a set of predefined rules. There's 7 of them here. I could go add my own. But here I have a rule that says I want to restrict SSH access. I want to make sure that port 22 is not open to the whole world. And I've opened it to be productive, just a case in point. And I forgot to turn it off. So I'll create this rule and make sure that I'm safe. So it's really simple. I didn't have to configure anything. You just click on the rule, and you're getting started. And basically, then Abhishek comes in.
So this is what happens when you let product managers touch your infrastructure. Okay. So I see my stacks running, but I'm not able to SSH in there. What am I going to do? Well, let me open my stack in the designer. What you're seeing here is the new CloudFormation Designer capability we released last week. I can see my web server instance, and I can see it's talking to a security group. I can see all the configuration for that in the template view right here. And I notice that only port 80 has been opened. Well, that's no good. So let me type up quickly the ability to open a TCP port. And now who remembers what the SSH port is? I don't. So you know what? I'm just going to open everything. So there we go. And now I should probably look up my IP range, but you know what? Forget about it. So in this case, let me find what is the easiest thing I can type up. Do not take a picture of this, please. Okay. And with that, let me refresh my changes. They look good. Validate the template. All my changes look great. Upload the stack. How's about that? So productive, but comes with dangers. So anyway, here, just as an example, I showed you how anyone at any time with the best of intentions can go and make updates which could be
potentially harmful, right? And you know, I don't blame him. He's new. He's trying to get productive. He actually does this because he has to get something done. But you know, in the background, I now see that my restricted SSH actually has one non-compliant resource. So I have this rules dashboard that tells me that Abhishek's actually opened up an SSH port 22. In fact, he's opened up a lot more than that. So I can click on the restricted SSH rule here, and I see that it's working correctly, it's monitoring things, and I also notice that now that security group that he just opened up is non-compliant with this resource. That seems weird, so I'm going to go to the AWS Config timeline view of that security group and then look at what changes were made to that. So you can do that by clicking the little timeline icon. And I notice there's a change here where that just happened recently, where I can go in and then look at exactly what Abhishek did, which is open up in not really port 22, but pretty much everything, right? So that's no good. I detect this, and you know, before I can go back and sort of smack him on the head with something, I have to close it. I have to fix this problem. So I go to managed resource, which is a link on the AWS Config console, where you can go to the EC2 console to get to the security group. And then I see that he's actually done this. Look at the inbound rule. And you know, instead of being nice, I'm going to just say, I'm going to quarantine this thing. I'm just going to delete this rule and just isolate that resource completely. So I click on edit, hopefully. And then I can delete this resource. So when you go back and look at the resource in the AWS Config timeline view, you'll see that it's compliant. But this is not all that you can do. You can actually you can go one step further and write your own rules. Now you can codify your own best practices and write it in any language that Lambda supports. And we'll take a look at how you can do this. If you're not, you know, if you don't have time to write your own rules, if you prefer using rules that are vended by somebody else, you can also use rules that our partners will write on this on this infrastructure. Writing a custom rule is actually quite simple, and you know, it's really simple because I was able to do it, and I'm witness to the fact that it's simple. You add a custom rule in the console. You set up all the descriptions and name and everything like that. You go to Lambda and you write up very easy code. In this case, it's JavaScript, so you don't have to write any of this. So basically, all of this is boilerplate code. I actually modified 2 lines. I'm checking here whether the instance that was launched is using an approved image, AMI that was approved. So I have approved image 1 and approved image 2, and those are the only 2 lines I actually changed in this. Entire code is actually available in the documentation, so you can actually create your own rules using that. So I come back to the AWS Config console, and I say, OK, I have these 2 approved images. At the bottom of the screen there in the parameters, you see that I have 2 AMIs that I've typed up as approved. These are parameters that are passed to the function, and this function is evaluated and checked on a regular basis. So you can really go crazy with this. You can write your own rules. You can, you don't even have to use the configuration items that we provide. You could go call APIs that are outside of AWS to check temperature in another country or something like that. It's completely in your hands. If you look at the partner ecosystem that's building around this type of capabilities, you'll see that you have various partners integrating with this, building rules for specific compliance needs. And you can actually just use them to get started instead of if you don't like to write your own rules. So we looked at AWS Config as a way to track your resource inventory and changes to your resources. And you can now set up this continuous compliance. So every time a config rule executes, you're actually checking to make sure everything's OK. And as soon as Abhishek opened that port, you saw the rule becoming non-compliant. I can go ahead and actually edit, change that resource, and then I can see that it's actually working. It's a state of continuous compliance here instead of actually checking it on a timed basis. You can also stream notifications, and you can say, I have this SNS topic that I've set up where I'm going to continuously receive all the changes that are occurring in this account, so I can keep tabs on them. You can write your own script to parse out things that you think are interesting. So that's, this services together. When you look at Service Catalog, you're provisioning things in a very standard form. CloudTrail is helping you log these API calls, and Config with config rules is helping not just monitor these resource changes, but also detect and even take action on them. So everything you saw me do in the console with click on managed resource and like quarantine the security group, you can actually write that in Lambda code itself. So it can be automated. Now, one important thing to think about when you look at these management services is this is not security. It's not somebody else's problem. It's not enterprise management tools. These are all coming together. So security operations, enterprise management tools, all of these are developer tools, right? These are all tools that you use to make developers productive. So I'd encourage you to think about these as tools that you can use and use together. So really, the best way to do this is to try these services. So Service Catalog helps you standardize these resources so you can provision things that are completely approved by your administrator. You saw how you can use CloudTrail to track API activity on these resources and make sure that you can get alerted if an API activity that you weren't expecting happened. And you can use AWS Config to actually track the configuration of these resources and set up config rules that help you make sure that things like what you saw are not happening. Config rules, I should mention, is actually in preview after Wednesday's launch, so you can sign up for preview at awsamazon.com/config/preview. That's pretty much all we had.
Thank you so much for joining us today on Friday morning.